Hello students, let's begin lesson 5, Systems of Linear Equations. Previously in lesson 1 and also in lesson 2, we went through various types of linear equations, but they all had one variable per equation, not like this. Here in lesson 5, let's study systems of linear equations that consist of more than one equation with more than one variables. Here's a motivating example. We have 2x plus 3y equals to 6, and that's the first equation, which I'm highlighting in blue. And the second equation is x plus 4y equals to negative 1. Okay, there you go. Now, how do you solve it? In other words, how do I find xy values that satisfy both? Well, before going ahead with algebraic means to solve it and getting the answer, let me show you the answer visually so that you can make a reasonable guess first. So here we go. 2x plus 3y equals to 6, x plus 4y equals to negative 1, and x going from negative 5 to 5 and y going from negative 5 to 5 as well. That's just an initial guess. I can change it later. And then okay, don't pay too much attention to all those mathematical commands. Just look at this. First equation, 2x plus 3y equals to 6. And the second equation, x plus 4y equals to negative 1. And here's the plot. Let's see, something interesting is going on here, but it's outside the viewing window. So let me change the viewing window from negative 5 to positive 5 to negative 2 to 8. Same size, but shifted a bit to the right. And let's keep the same y window. And there you go. We have the crossing point right here, and that's got to be the solution. Why? What do you mean by this first equation, 2x plus 3y equals to 6? That corresponds to this blue line. More precisely speaking, all the points x comma y on this blue line must satisfy the blue equation, 2x plus 3y equals to 6. Same goes for the second line. X plus 4y equals to negative 1 corresponds to this red line. So x comma y that's satisfying this equation, x plus 4y equals to negative 1, must be on this red line. Now we're looking for x comma y that's satisfying both equations. That means that point must be on the blue line and also on the red line because it satisfies both equations. And that point is right here, the crossing point. Just by looking at it, this crossing point is approximately speaking, I don't know, about 5.5. That's my initial guess. And then y-coordinate about negative, again, just a guess, negative 1.5, approximately speaking. Anyway, that's my guess. And that's what I can get from graphics. Now let's find the precise solution through algebraic means. How do you do that? We're going to consider two types of methods. One is substitution method, which we're going to study right now. And then the other method is elimination method, which we will study in a separate video. So how does the substitution work? Pick an equation, solve for one variable, and substitute it into the other equation. So which equation and which variable shall I select? I'm going to select the second equation and solve for x. X plus 4y equals negative 1. And solving for x, x equals a negative 4y minus 1, like this. Why did I select x from the second equation? That's because it has the simplest coefficient. Coefficient 2, 3, 4 versus coefficient 1, that makes it the simplest. So I don't have to divide by anything. If you solve for y, for example, in the second equation, I can flip this x to the other side and I'll have to divide by 4, like this. X plus 4y equals negative 1. 4y equals to, flipping over, negative x minus 1. Y is, I have to divide by 4. Negative 1/4 x minus 1/4, like this. I'm going to get fraction with all those denominator. Not impossible to do it this way, but it's harder. It's going to be easier if I do it this way. Alright, I solved for one variable successfully. And let me highlight this in green. And let's use the green equation and substitute it to the original equation. Which one? I have to use the first equation. This green equation actually came from the second equation, red. From this red, yeah, this is same as original equation, so let me use red. And the solve for x, that's how I got green. If I put it back into this red without using this blue, then I'm not going to get anything. I'm not going to get negative 1 equals a negative 1. That's not going to help. So let's put it into the original equation, blue. 2x plus 3y equals to 6. See? The original equation, the other equation, blue. And here, I'm selecting this x. And that's substituted by negative 4y minus 1, as I highlighted in green. So from the first equation, 2x plus 3y equal to 6, substitute x by negative 4y minus 1, as we have over here. And then what's the result? We ended up with an equation which is much more complicated, yes, but just one equation. Previously we had two equations, now we have only one equation. It's a step up. Solving this equation and solving for y is something we can usually do easily because we already went through all those tricks. Step 1, parentheses. Step 2, excuse me, what is step 1? Step 1 is denominator. It's just that I don't have denominator, so the next step is parentheses, and then the like term. Well, let's go ahead and do this. Negative 8y minus 2 plus 3y equals to 6. Did I do this right? Taking the like terms together, negative 5y minus 2 equals to 6. Negative 5y equals to 6 plus 2, so that's 8. Therefore, y equals to 8 over negative 5, or negative 8/5. Sorry about the typo. While speaking and typing at the same time, it's often difficult. Okay, I found one of the two roots. I need both x value and y value. I found y value. Now, how do I get x value? I'll have to put it back into one of those equations I already have. I can put it back into the first equation, blue, or the second equation, red, or this one, green, and that's what I'm going to use. The green equation here is actually a variation of the red equation. I algebraically manipulated red, so it's the same as red equation, but it's the most convenient. I already solved for x, so putting this one into x equal to negative 4y minus 1, that is, x is negative 4 times negative 8/5. Minus 1, and what is this? Negative, negative, positive, 4 times 8, 2, 32 over 5 minus 1, and 1 is 5 over 5, so what do we have? 32 minus 5. 27 over 5. That's it. There goes the full solution. Let's see, what did I do here? The same. Solve for x from the second equation, red, and then substitute it into the first equation, blue, and then break up the parentheses and take the like terms, we get the y value. Now substitute it back into the original equation, either blue, red, or this one. And then simplify, we got this. 27/5, comma, -8/5. In decimal, 5.4, comma, -1.6. Well, my initial guess was 5.5, comma, -1.5 just by looking at it. I guess I made a pretty good guess to begin with. Okay, there goes the solution by substitution. Now we don't have enough time to go to elimination method, so instead let's go to an example problem and then utilize a substitution method. Let's see, we have two questions here. We do not have enough time to complete even one of them, so let's go ahead with this one and then I'll give you a partial solution. Okay, we have the first equation, 7x minus 2y equals to 1, and then the second equation, 4x plus y equals 2. Now, which variable would you like to solve from which equation? I hope everybody got correct response. From the second equation, 4x plus y equals to -2, solving for y equals to -4x minus 2. Why did I select y from the second equation? Look at the coefficient. 7, 2, 4, this is 1. So I don't have to divide by anything. For example, if I want to select the first equation and solve with respect to x, I'll have to divide by 7. Dividing by 2, dividing by 4, and this one dividing by 1, in other words, no division. So that's the simplest. That's why I selected the second equation. And then if I substitute this back into the first equation, which I did not use yet, we get 7x minus 2, and then that is -4x minus 2. We have an equation, but only with one variable. So solving this, you're going to get the x value. And then get the x value, substitute it back into an equation, but this one is going to be the most convenient. Do your computation, you're going to get y value as well. I'll leave the detail to you. If you do it right, you're going to get this answer.